In this video, we will talk about p-values. And so it's important to understand what have we done so far, right? So far we have talked about how we test hypothesis about the population parameters using our traditional approach. So first we state the null hypothesis and the alternative hypothesis, then we choose a significance level, and then we determine the critical values by looking up the tables, okay? And once we have the critical value, then we use the value of the t-statistic. So we use the value of the t-statistic and check whether that is greater than the critical value, okay? At some sort of significance level. Let's say it's 5%, okay? Now, this is what we've done so far, but remember that here we are trying to specify a level, the significance level of the test ahead of time, right? So we are actually, before we go checking what the critical values are, we need to know what level of significance, what the level of significance is of that test, okay? So we can take an alternative approach, and this might be easier than the traditional approach that we were talking about. So rather than specifying the level ahead of time, whether it's 10% or 5% or 1%, we could try to answer the following question. So we could ask, given the observed value of the t-statistic, right? So we always know what the t-statistic is, right? Only for the critical values, we need to know what the significance is, right? So given the observed value of the t-statistic, what is the smallest significance level at which we can reject our null hypothesis? So if we can answer this question, this is going to make our lives a lot easier, okay? So the smallest significance level at which the null can be rejected is known as the p-value of a test. And we'll see what that means. Okay, so the p-value, it's really a probability that we are measuring. Okay, so this is a probability. Okay, and it is a single number lying between 0 and 1 that allows us to carry out the test at any level. Another way to think about p-values is that it uses the observed statistic, the t-statistic, as the critical value, and then finds the significance level of the test using that critical value. Okay, and typically your softwares report p-values for two-sided alternatives, and that's what we will be seeing. Okay, so in defining what the p-value is, as far as that two-sided alternative goes, we can write the p-value in this form. So we can say this is a probability where small t is the t-statistic and big T is the random variable that follows a t-distribution. Okay, so like I said before, this is going to be between 0 and 1. And another way, and maybe the best way to think about the p-value, is that it is the probability of observing a statistic as extreme as we did if the null hypothesis is true. Okay, so I think this will all make sense when we take examples. So if the p-value is equal to 0.5, then we are saying that there is a 50% chance of observing a t-statistic as large as we did, okay, in absolute value terms, okay? If the p-value is 0.001, then the chance of seeing a t-statistic as extreme as we did is 0.1%, okay? So here we can conclude that we got a very rare sample, or the null hypothesis is very likely false in such a case. So when the p-value, typically, if the p-value is less than 0.1, which is to say that the p-value is less than 10%, we are rejecting the null. We reject the null at 10%, okay? If the p-value was 0.05 or 5%, then we would reject the null at 5%, okay? So the smaller the p-value, the higher the likelihood that you would reject the null, or the higher the likelihood that the hypothesis that we set up, the null hypothesis, is very likely false, or we have to reject it, okay? But typically we would reject the null at values less than 10%, okay? And we would say that that's significant. Now, the p-value given by this expression here, we can see that as the absolute value of t increases, the p-value is going to decrease, okay? So in other words, we can come up with some sort of a relationship between the t statistics and p-values. So as the t statistics increase, p-values typically fall. And you can see this many times when you look at your regression output, okay? So we can take an example here and we can see if the degrees of freedom were 40 and we had a t statistic of 1.85 or negative 1.85, then we can compute the p-value. We can say what is the probability that the absolute value of t is greater than 1.85. And since we're talking about absolute values, we've taken the positive and negative values. This is just going to translate into 2 times the probability that t is greater than 1.85. And this is going to be equal to 0.0718. Okay, so when you get a p-value, which is 0.0718, we're basically saying 7.18% is the significance, is the smallest significance level at which, this is the smallest significance level at which we can reject our null hypothesis. So once we know what the p-value is, we can carry out a test. And the rejection rule is, this is the rejection rule when you're using p-values. Rejection rule basically says that reject the null hypothesis if the p-value is less than alpha. And alpha is the chosen significance level of the test. So if you're carrying out the test at 5% and the p-value is 0.03, which is 3%, we're saying that 3% is less than 5%, and so we would reject the null, okay? If the p-value was greater than 5%, then we would fail to reject the null. Okay, so in this case, for example, where the p-value is 0.0718, if we were to interpret this, we can say that we fail to reject the null at the 5% level. Okay, so if the p-value is 0.0718, then we fail to reject at 5% because this is approximately 7%, right? So 7% is not less than 5%, right? So this was the rejection rule. If 7% is not less than 5%, we fail to reject. Otherwise, we would have rejected, okay? But at 10%, we can reject it, okay? So 7% is less than 10%. So if our alpha was 10%, we can say we reject the null at 10%. Okay, so it's very easy to compute p-values for one-sided alternatives if you wish to do so. Okay, typically, like I said before, statistical packages would report only the two-sided p-value, but the easy way to compute a one-sided p-value is to take the two-sided p-value and divide it by 2. Okay, so we basically are focusing on the area in one tail and not the area in two tails, right? So the two-sided p-value is giving us the area in both tails. So if we go back to this diagram here, this is when we are thinking about the two-sided test. And if you compute, what this is equal to, if you say if you multiply this, then you should get 0.0718, which was our p-value. Okay, so that was for our previous example. Okay, so if you look at your regression output in R, there would be a column that is labeled what is the probability that of t, the big T, being greater than the t statistic, and that's your p-value. Okay.